potential, right? So this is a very important topic in the CO2 action potential. So if you have a look at this picture, so this is the neuronal cell, this is the cell body, this is the axon, and these are the dendrites, and these are the axon terminals, and then the nerve signal is moving from the head to the, you can call it as tail or the axon terminal, and then it will move on to the next neuron, right? So these are the dendrites, and then it will move on to the next neuron, and then the signal will move from one neuron to the another neuron. If you have a look at the GIF here carefully, you have all the positive charges on top and all the negative charges inside. This is the outside the membrane, and this is the inside the membrane. So when the cell is, neuronal cell is in resting condition, all the positive charges will be there on the top and all the negative charges will be there on the bottom or towards the inside of the membrane, right? So this condition is called as resting membrane potential, right? So now if you have a look at this picture here carefully, slowly the negative charges are moving to the outside, and the positive charges are moving to the inside. That means the depolarization is happening. So when the depolarization happens, then you can see a spike in the electricity, movement of the electricity from one direction to the to the end of the axon, and then followed by a repolarization. During the repolarization, it's a reverse happening. If you see here carefully, the negative charges are going up, and then positive charges are coming back. This is one action potential followed by another action potential. Likewise, there will be depolarization, repolarization, and then RMP. It's continuous throughout the axon, and then it will move on to the next one. So this is the graph which shows resting membrane potential is generally at a minus 70 millivolts, and a depolarization condition, it can go till plus 30 millivolts, and repolarization, it will get back to the actually it's go a little down the minus 70, and then it will go back to the minus 70 condition. This is called resting membrane potential, and this one is depolarization, and this one is because of repolarization. Okay, so let's have a look at this particular picture. You can see the steps involved in the action potential starting from here. This is 1, 2, 3 and 4 and 5. Okay, so the first step, so this is the membrane, neuronal membrane, and you have some ion channels, okay, on the neuronal membrane. So these are sodium ion channel, these cream color ones, and this brown color ones are potassium ion channels. So when the membrane is in resting condition, all the channels are blocked. That means there is no transfer of any ions through this channel. And to be you need to understand one point: sodium ion channels will allow only sodium ions, and potassium ion channels will allow only specific potassium ions. So you can see here sodium ion bouncing back at the receptors or at the channel because it's been blocked, and this potassium ion also it's been blocked because this is entire channel is blocked. So this is during the resting stage. All channels are blocked, and entire inside of the cell will be negative, and entire outside of the cell will be positive in charge. Okay, so when come to the second step, that is called depolarization. So the first thing that happens during depolarization is one of the several sodium ion channels will open. So this leads to the movement of sodium ion from outside to the inside. As we all know, sodium ions are positively charged ions, and inside is negative. So there is a positive charge building up inside the inside the membrane, and there will be slowly negative charge will be there on the outside the membrane. This leads to the depolarization. This condition is called as depolarization. Slowly the third step will be, there will be a rise in the action potential. That is because here in this case, second step, only one sodium ion channel or only few sodium ion channels are open. Here several sodium ion channels are open, so many sodium ions will be passing through these channels, and slowly inside will become positive, more positive, and outside become more negative. Okay, this condition is called as depolarized condition. If you have a look at this action potential here, so this is the step number 2, where when only one sodium ion channel open, and this is the step number 3. There is a spike in the potential because several sodium ion channels are open, and it reaches till plus 30. So it was there at minus 70 millivolts, it went till plus 30 millivolts maximum, right? So this is the third step. And the fourth step is where a repolarization condition happen. So in this case, what exactly happening is, you can see the potassium ion channels are open and sodium ion channels have been blocked, right? All the sodium ion channels are blocked and potassium ion channels are open. So this time potassium ions will move from inside to the outside. So till now sodium ions move from outside to the inside, that's why inside become positive and outside become negative. So there is a depolarized condition, and when the sodium ion channels are closed and potassium ion channels open up, the potassium ions will move from inside of the cell, neuronal cell, to the outside. So slowly positive charge will start building up and negative charge will start building up inside, positive charge on the outside. So slowly the repolarization starts, and then it will come back to resting membrane potential. So before that, you can see this is the resting membrane potential, which as we discussed, minus 70 millivolts. There is an undershoot here. Undershoot means this repolarization went a little down further, right? And then is the first this is the step number 5. So this is called as undershoot, and then it will come back to the resting membrane potential. Why this undershoot happens? Because the opening of sodium ion channels will take some time. So during that time, the potassium ions will be keep moving out, and more positive will be accumulating on the top and negative in the bottom. So repolarization go down little further. This condition is called undershoot. So this undershoot will be stopped when the sodium ion channels open up. Okay, whenever sodium ion channels open up, again the membrane potential, resting membrane potential will be reached, that is minus 70 millivolts, and then it will the action potential will continue. So this entire thing is one action potential. So similarly, again the sodium ion channel will open up, sodium ions will move in, and then the potassium ions will move out. Again another spike, another spike, another spike. Likewise, the movement of the signal inside the neurons happens in the form of spikes of millivolts of current that is passing across the membrane. So this is happening because of the movement of ions across the membrane. Okay, so this is about the action potential and various steps involved in the action potential. I hope you understood the concept. So let me close this session here. Thank you.